Hello, this is part two of right triangles. So let's just continue. So on example four, it says solve for x. So x is not an angle, it is a side length. Um, so what should we use? SOHCAHTOA or Pythagorean theorem? We cannot use Pythagorean theorem because we only have one known leg, right? We need to have at least two known side lengths. So we'll have to do SOHCAHTOA. And what shall we use? Let's see here. With this, in this case, we do have to have one known and one unknown. Um, so sine will not work because we don't know what hypotenuse is, and we don't really care about the hypotenuse. We only care about x, which is a leg. I don't think cosine will work because uh we would have two unknown values. We need to have at least one known and one unknown. So I believe that tangent will work. And the angle we're going to use is 30. Yes, you could figure out what this angle is, which will be 60 because the sum of a triangle adds up to 180, right? But you don't have to if you don't want to. So you could do tan of 30 degrees, which is opposite over adjacent. So from this angle, where do you think the opposite side would be? It would be 30 over the adjacent side, which is x, right? Cross multiply, so x times that is x times tan of 30 degrees. And then 1 times 30 is 30. Now, later on, you'll know that when we go over the unit circle, tan of 30 could be an exact value. It would be 1/2 over radical 3 over 2. So that is 1 over radical 3. But it's a fine. We haven't gone over that. So you could just put this in the calculator. So to solve for x, you're going to divide both sides by tan of 30 degrees. So this cancels. So you're left with x equals to, just put this in the calculator. If you want, put it all to be, so you don't make mistakes, put this in parentheses, divided by, and then put all this in parentheses. Okay, make sure you are in degree mode because we are in degrees. So I put that in the calculator. I get 51.96. Let's just round to whole numbers because everything else is in whole numbers. So it would be 52. So this leg or the side length is going to be 52 units. Okay, go ahead and absorb that. Move on to example 5. Okay, so example 5 says we have a right triangle. We got to find side length y. So it's a leg. So we can't use Pythagorean because we need at least one other leg value. So we can't do Pythagorean. So we're gonna have to do SOHCAHTOA. And what shall we use? Well, first let's pick our angle. We can use this angle. You could find out what this angle is, which is 30, because 60 plus 30 is 90, plus 90 is 180. But it doesn't matter. You could use 60, and I'll use 60, and I will use, should I use sine, cosine, or tangent? I think sine will work perfectly because it gives you a one unknown and one known value. So sine of your angles, so in our case, our angle is 60, which is opposite. So from angle 60, the opposite side would be y, over my hypotenuse, which is 18. Okay, cross multiply, so 1 times y is y. And then on the right, it's 18 times sin of 60 degrees. So 18 times sin of 60 is put exactly like that in calculator. 15.588. Since everything's in whole number, we could round it to 1 decimal, it's fine. So it would be like 15.6. Okay, so that is your unknown side length. Let's do the last example. Solve for small r, or the hypotenuse. Could we use Pythagorean theorem? No, because you need to have another leg or another side length. So we're gonna have to do SOHCAHTOA. So first figure out what your angle you're gonna use. I'll use this angle, 45. And I need something related with a hypotenuse. So it's either sine or cosine. I think sine will work, and I'll show you. So if you do sine of your angle, 45 degrees, which is opposite over hypotenuse. So from this angle, 45, the opposite side would be 20. And then your hypotenuse will be small r, your unknown, right? Cross multiply, to solve for r. So 1 times 20 is 20, equals to r sin of 45. Later on, you'll see that sin of 45 is radical 2 over 2. But right now, you can just forget about that and just put it in the calculator. So this cancels. So you're left with r equals to 20 over sin of 45 degrees. And if you put that in the calculator, you get 28.28. Okay, so that, oops, let's just round it to 1 decimal. So the hypotenuse is going to be 28.2 units. Okay, so yeah, that wraps it up for this section. So I will end here.